Welcome to ECE 401 Senior Design 1. Now, Senior Design 1 is kind of a fun course. It's really a lab course. If you're tired of courses where you just push numbers on paper and you want to build something, this is the course for you. So by the end of Design 1, you'll be building custom circuit boards, kind of like these. These are circuits from previous semesters. This is a little 2-inch by 2-inch board that's a light detector. When I have a shadow go over the sensor, the light turns on. So with that, at a counter, I can tell you how many times the refrigerator door has been opened. This is a microprocessor, a Raspberry Pi Pico, driving a stoplight, going green, yellow, red, green, yellow, red. And here's a board with just a 555 timer and a comparator. When it gets below 0 degrees, which I'll simulate by turning this knob, an alarm goes on. So that's kind of the goal of Senior Design 1. Design, test, build, lay out a PCB, populate the PCB, test it, and demonstrate a circuit board like this by the end of the semester. The reason for that is when you get to Senior Design 2 and 3, you'll be designing custom circuit boards for a given project. First time's always the hardest. So in Design 1, the goal is to have you go through the process of building a fairly small circuit board. So you see, how do you design a circuit, put it into Fusion 360, design a PCB, order the PCB, solder the PCB, build it, test it, and demonstrate it. So that's where we're heading. In terms of course administration, the instructors are Jeff Erickson and myself, Jake Lauer. Class time is Wednesday at 3 p.m. The room sometimes changes, but currently it's in ECE 125. Class is also offered on Zoom. Our office hours, pretty much whenever doors open, we're available. The textbook is actually on Bison Academy. So if you go to Bison Academy, this is the semi-official website for the Electrical Engineering Department in NDSU. Scroll down to 401. That takes you to the homepage for Senior Design 1. Here you've got the schedule laid out on a weekly basis. All the lectures are available in PDF format. The videos, aren't any videos yet, but shortly there will be videos. They'll be posted, so those of you taking the course online can watch the lecture. The homework assignments are on the right. So basically, if you have problems, go to this website. Other important things are parts inventory. If you want to know what parts we have in stock, click under Parts Inventory. This brings up a great big spreadsheet, and you can do a search. Just do find MCP 602. It'll tell you, do we have it? And yes, we do. And it is in Jeff Erickson's office in bin B2105. So this is kind of a useful link. It makes our life a whole lot easier if you know where to find the part. There's thousands of parts in Jeff's office. What else is in here? Under Resources, MATLAB. Another thing on Bison Academy is in Senior Design, the point of Design 2, Design 3 is to demonstrate that you can apply knowledge of electrical computer engineering. If you forget or you need a refresher, well, here's Bison Academy. If you forget something about circuits, you can go back to circuits, and here's the different lectures in PDF format and YouTube videos. If you forget about electronics, here's lectures on diodes, transistors, amplifiers, filters, stuff like that. So pretty much it's a useful resource to go back. Or more, if you need to go back and try to remember how did this work. The prereq for this course is Circuits 1. So if we look at, say, the computer engineering curriculum, here's the courses you need to graduate in computer engineering. Right here is Design 1. As soon as you finish Circuits 1, you can start taking Senior Design. We kind of did that so you can graduate quicker. However, when you get to Design 2, Design 3, in Design 2, well, the whole point behind Senior Design 2 is to demonstrate that you can apply knowledge of electrical computer engineering. Now, in theory, I could take Circuits 1, Design 2 without taking any other courses in electrical engineering. Please don't do that. When you get to Design 2, you are required to pass. In order to pass, you are required to apply knowledge of electrical computer engineering. Basically, can you apply what you've learned over the last 4 years? To do that, you need some knowledge of electrical computer engineering. So the assumption is you have taken some other courses so that you can apply that knowledge when you get to Design 2 and Design 3. So in spite of the way the curriculum is laid out, please don't take Design 2, Design 3 until you've had some courses in electrical engineering. Otherwise, you're going to have a hard time applying what you've learned. But anyway, back at the ranch. The prereq for Design 1 is 206. Now, the way senior design is laid out is Senior Design 1, 2, and 3 is a 3-semester sequence. In Design 1, we take you through the entire design process. So you go from, we talk about project management, how to organize a project, some of the tools you'll be using, like oscilloscopes, function generators, Fusion 360 for laying out a PCB. We'll then take a small project, like a stoplight, on-off light sensor, define the requirements, set up a timeline when you're going to get everything done. It's got to get done by the end of the semester, so there's kind of a time crunch. Design your circuit on paper, check it in Circuit Lab on simulation, breadboard it to make sure your design is correct. Once it works on a breadboard, transfer your schematic to a PCB, lay out the PCB, order it when it comes in, populate the PCB, build it, and then test your PCB. That's your validation and documentation. Now that's what you're going to do in 401. When you get to Design 2, Design 3, you'll do the exact same process, only for a much larger project. Now the first time is always the hardest. That's kind of why we have Senior Design 1. In Design 1, you kind of go through the entire design cycle on a small, more manageable project in a group of 2, so that when you get to Design 3, you're ready to dive in. The expectations in 401 is that by the end of the semester, you should be able to use schematics capture, basically Fusion 360, to design a printed circuit board. You should understand the process for selecting components, basically how to read data sheets, understand PCB material considerations, understand the basics of soldering and rework techniques. Basically, when you have one of these boards, you'll need to solder it together, and if you're lucky, it works the first time. Typically, it doesn't, so you'll have to fix it. Sometimes you have to adjust one of the components. That's your soldering, reworking. Get the circuit to work. You should understand some of the basics of project planning and project management. Understand some basics of safety engineering and use of lab notebooks for documentation. So that's kind of the expectations for the course. Basically, the goal is come up with this circuit and document it in a thing called OneNote. Now the textbook for this course, as mentioned, is Bison Academy. On Bison Academy, you've got all the lectures. We'll have recorded lectures once I'm done with these recordings. The class is offered in the full HyFlex mode. What that means is the class is offered 3 ways. You can attend in person, that's Wednesdays at 3 p.m. You can live stream the class. All classes will be live streamed on Zoom. You can also watch the class on YouTube. That's for the online students. Now, how you take the class is up to you. Online is available to everyone. Zoom is available to everyone. So attend however you like, but do attend one of those ways. In terms of grading, this is really a lab course. There are no midterms. The homework is 100%, your grade is based 100% on the homework. And the grading is straight scale, rounded to the nearest 1%. So basically, if you do all the homeworks, you wind up with a working circuit board, you should get an A. As mentioned before, the objective of the course is to go through the design cycle so you wind up with a working PCB. That's something you're going to be using in Design 2 and Design 3. So part of the goal of this class is to get you familiar with some of the tools you'll be using in Design 2 and 3, such as Circuit Lab to simulate your circuit, Fusion 360, that's your schematics capture and PCB layout, soldering through-hole components, and using oscilloscopes and multimeters to check and validate your design. By the end of the semester, you should have an original PCB that you designed. It's either 2" by 2" if there's no microprocessor, or 2" by 3", kind of like this puppy, if there is a microprocessor. You'll have one circuit board per student, so it's yours to keep. You can use it as a Christmas tree decoration, put on the refrigerator, whatever you like. It's also kind of nice when you go to interviews for jobs. You can bring it on along as a prop and talk about what you did in senior design. In terms of the syllabus, and the syllabus is probably easier to see on Bison Academy. So if we go back to Bison Academy, here's 401. The first week of the semester, we'll be going over the syllabus and a list of projects that you can build. The second week, we'll cover project management and OneNote. OneNote is basically your design notebook. It's an electronic notebook that we use for senior design. It makes senior design work really, really well. It used to be there was this heinous 50-page report at the end of the semester. With OneNote, you don't have to do that. OneNote's basically your diary, so put all the information in OneNote as the semester goes along. And at the end of the semester, your OneNote document is your final report. Basically, you submit your homework in OneNote. In week 3, we'll go over breadboards and using a microprocessor like a Raspberry Pi Pico. Now, most people have not had experience programming a Raspberry Pi Pico. It's actually very friendly, very easy to use microprocessor. It's what we use in advanced embedded systems, 476. But if you've used MATLAB, you basically know how to use Python and how to use a Raspberry Pi Pico. We're using the Raspberry Pi Pico because when you get to Design 2, Design 3, the Pi Pico is a very popular processor. It solves a lot of problems. So in this class, if you do use a microprocessor, we recommend Pi Pico. In fact, we require the Pi Pico. It transitions very well to Design 2, Design 3. On week 5 is a career fair, no class. It's week 4. Week 5, we'll go over Circuit Lab and op amps. Basically, that's a Circuits 1 review. Week 6, go over diodes and transistor. That's electronics review. Now, many students, they have not had Circuits 2. They have not had electronics by the time they get to senior design. That's okay. We'll cover what you need. And if you really want a refresher, again, what you do is just go back to electronics. You want to know, how do I use a transistor as a switch? Well, here's a lecture on using a transistor as a switch. We'll then go into Fusion 360. Fusion 360 is the software we use for laying out a circuit board. There'll be 2 weeks. The first week is transferring your breadboard design into a schematic on Fusion 360. Then the next week is take the schematic and convert it to a circuit board, PCB. At that point, once you get your PCB laid out, we'll order the boards. About 10 days later, the boards come in. And in the meantime, we'll have a little practice soldering board. That's one of these kits we'll hand out. Every student gets one, so you can practice doing some through-hole soldering. Practice makes perfect, so the goal is to practice on these boards, get your soldering technique down, so that when your PCB does come in, it'll be the second time you've soldered, so it should go a little bit better. Next 2 weeks are using test equipment. It's kind of an in-class quiz where you demonstrate you can use a multimeter, use an oscilloscope. Our goal is by the end of senior design, everyone who graduates should know how to use a multimeter and an oscilloscope. We'll then go over the final report. At that point, the class is basically over for meeting in person. The rest of the semester, we'll be meeting individually with your design groups. Basically, your PCBs come in, solder it up, get it working. During Dead Week, you'll schedule a half-hour presentation where you demonstrate your circuit board works. You should have one working board for every student in your group. There's also the Senior Design Expo. Not exactly sure when that'll be, but that's usually during Tuesday or Thursday of Dead Week. That's a chance to go in and see what the Design 3 students have made. So that is the syllabus for Senior Design 1. In terms of the homeworks in this class, again, 100% of your grade is based on the homework. The first homework set is pick a project. There's 12 projects to pick from. Pick one. We'll talk about that in a sec. The second week is to do some project management. Organize your project into the project requirements, project breakdown, major activities, and tasks. The tasks are basically the homework sets. Those are spelled out for you in 401. In 403, 405, Design 2, and Design 3, you'll kind of need to specify those because each project's different. Also in homework set 2, you set up your OneNote document. OneNote document's basically an electronic diary where you keep everybody in your group updates the same OneNote document. When you submit your homework set, basically Jeff and I just look at your OneNote document. Your submission is basically OneNote. Homework 3 is a paper design. Once you know the requirements, calculate the resistors, capacitors to meet your requirements, and update your OneNote document with the calculations and your schematics. Homework 4 is check your schematics. Does your design work in simulation? Here we'll be using Circuit Lab. What Circuit Lab does is you can sit there and check to see if your design works. By works typically means the current through the diode is 20 milliamps plus or minus 5. 9-volt batteries converted down to 5 volts, stuff like that. What's nice about Circuit Lab is if your design doesn't work, it's very easy adjusting the components so that it does work. It does meet your requirements. Once your design works in simulation, it's build it on a breadboard. Verify that it really does work in hardware. Once the breadboard works and you finalize your schematic, transfer the schematic to a program called Fusion 360, and in Fusion 360, design a PCB. The PCB will look like this, something like this. It's got all the different components that are soldered in. What's nice about a breadboard is a breadboard, well, these don't work. After a couple weeks, components fall out. A soldered circuit board, that should last. Once you get your circuit board designed, send Jeff your Gerber files. We'll order them. You'll get 5 PCBs, 1 for each student plus spares. And it takes about 10 days to order the PCB. While we're waiting for the boards to come in, we'll give out a practice soldering kit so you can practice soldering your boards, see how to solder through-hole components, compare lead solder versus lead-free solder. Once your board comes in, now solder your actual board, test it. To test it, you'll be using things like oscilloscopes and multimeters. Homework set 8 is to verify that you know how to use multimeters and oscilloscopes. Basically, given a small circuit, take some measurements using both, verify you can use both multimeters and oscilloscopes. And then the final report is, once you get your circuit board built, populated, and tested, demonstrate it. Come in for a half-hour demonstration where you demonstrate that each student's circuit board does work. And there's also 11 by 17 poster, kind of summarizing Senior Design 1. So that's kind of Design 1, kind of a fun class where you actually get to build something. In terms of legal stuff, attendance is required. However, how you attend is up to you. It can be in person, live stream on Zoom or YouTube. If you have special needs, let us know. We'll accommodate them. Academic honesty, please do your own work. When you get to industry, you'll be designing defibrillators, pacemakers, flight controllers, fuel controllers. The stuff that we teach in electrical engineering is stuff you're going to need. It's better to learn it while you're in school than when you graduate and your boss quickly realizes you don't know anything. So please do your own work. If you're a veteran, again, if there's an instance, let us know. We'll accommodate you. That's the legal stuff. Now, in terms of the project list, let's go to Bison Academy. Here's a list of projects you can choose from. Now, this is homework set number 1. Pick a project. The projects you can choose from are a freezer alarm. That is a little alarm. I guess that's what this guy is. It's got a temperature sensor. When the temperature gets less than 10 degrees Fahrenheit, an alarm turns on. There's a binary counter, like this puppy. I wanted to count 0 to 15, 1 count every 0.5 seconds. I can count 0 through 9 with a light sensor. As I put a shadow in front of it, it just counts 1, 2, 3, counting up to 9. Basically, find out how many times your refrigerator door has been open during the night. Light sensor, that's like this guy. It's a night light. When it gets dark, the light turns on. When it's light, the light turns off. H-bridge motor driver. Similar, I want to be able to drive a motor forward or backwards using a single 9-volt battery. A stoplight. Have it go through green, yellow, red sequence. Door open with delay. Have a timer. When a switch is open, meaning door's open, it counts to 60 seconds. At 60 seconds, an alarm goes off. It stays on until you close the door. A mod 9 counter. Count up and down mod 9. Freezer alarm with a microprocessor. A paperclip counter. Every time I pass a paperclip or metal object by it, it counts. A Noyatron. Have it sleep for a random amount of time, wake up and go beep, 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 and then go to sleep again, just to annoy people. And a tone generator, basically build a doorbell. So when you push a button, it plays your favorite tune like doo-doo-doo-doo-doo-doo. Those are the options for the projects. They can either have no microprocessor, or if you want, you can use a Raspberry Pi Pico with a microprocessor. So homework set number 1 is to pick one of these projects and get into groups of 2. So that's kind of an introduction to standard design. It's a fun course where you get to actually build something. It's going to lead into design 2 and design 3, where instead of building something small, it'll be something much more significant. And that's lecture number 1 for standard design.